Hello everyone. In this video, I'm going to discuss socket programming in Linux. Firstly, let me tell you what a socket is. A socket is one endpoint of a two-way communication link between two programs running on the network. It allows transfer of data between two different processes on either the same machine or different machines. Sockets are bidirectional and the control follows a client-server pattern. Here, the client needs to know of the existence and address of the server, but the server doesn't need to know the address or existence of the client prior to the connection being established. And also, the client and server must agree on a protocol, that is, the language of the information transferred back and forth through the socket. When a socket is created, the program has to specify the address domain and the socket type. Let us now discuss the types of sockets. There are four types of sockets: stream socket, raw socket, datagram socket, and sequenced packet socket. Type 1: Stream socket. Stream socket uses TCP protocol, which is stream oriented. It is reliable and a connection oriented socket. In this, the data records have no boundaries. Type 2: Raw sockets. Raw sockets are very rarely used. They are used for creating a new protocol. Type 3: Datagram socket. It uses UDP protocol, which is message oriented. It is an unreliable and connectionless socket. Type 4: Sequenced packet socket. It uses SCTP protocol. Sequenced packet sockets are similar to stream sockets but have data record boundaries. The uses of sockets are to transfer data between two different processes in same system, to send command to the remote system, to download data from remote system, and sockets are used in a client-server application framework. Most of the application level protocols use sockets to establish connection between server and client and for exchanging data. Let us now discuss the second important thing that is to be specified during socket creation, that is socket address. Socket address is a combination of IP address and port number. The IP header contains the IP addresses, while the network layer protocol header contains the port numbers. Associating a socket with socket address is called binding. The socket address for a particular socket on a particular host is unique. Let us now move on to our next topic, system calls used by TCP socket. The system calls used by TCP client application are socket, connect, write, read, and close. The system calls used by TCP server application are socket, bind, listen, accept, read. Let us look into each system call in detail. Socket. Socket system call is used to create a socket. It accepts three arguments: family, which specifies the protocol family; type, which specifies the kind of socket you want; protocol specifies the protocol type. It returns socket descriptor on success, on -1 on error. Bind. Bind system call assigns a local protocol address to a socket. It accepts three arguments: socket descriptor, pointer to address, and length of address. It returns 0 on success and -1 on error. Listen. Listen system call converts an unconnected socket into a passive socket. It accepts two arguments: socket descriptor and maximum number of allowed connections. It returns 0 on success and -1 on error. Accept. Accept system call is called by a TCP server to return the next completed connection from the front of the completed connection queue. It accepts three arguments: socket descriptor, pointer to client socket address and length of address. It returns non-negative descriptor on success and -1 on error. Connect system call is used to establish a connection with the TCP server. It accepts 3 arguments: socket descriptor, pointer to server address and length of address. It returns 0 on success and -1 on error. Close system call is used to terminate the communication. It accepts a single argument socket descriptor. It returns 0 on success and -1 on error. Next, we are going to discuss the client-server implementation of TCP socket. As shown in the picture, a TCP client has to create a socket with the socket system call and connect the socket to the address of the server using the connect system call. It can now send and receive data using the read and write system calls. A TCP server, on the other hand, has to create a socket with the socket system call, set socket options using set socket option system call, and bind the socket to an address using bind system call. It listens for connection with the listen system call and accepts a connection received from the client using connect system call. It can now send and receive data using read and write system calls. Our next topic is system calls used by UDP socket. The system calls used by UDP client application are socket, bind, receive from, send to, and close. The system calls used by UDP server application are socket, send to, receive from, and close. Let us now look into each system call in detail. Socket. Socket system call creates an unbound socket in the specified domain. It accepts 3 arguments. Family specifies the protocol family, type specifies the kind of socket you want, protocol specifies the protocol type. It is 0 by default. It returns a socket descriptor on success and -1 on error. Bind. Bind system call assigns a local protocol address to an unbound socket for receipt of datagrams. It accepts 3 arguments: file descriptor, socket address, and length of address. It returns 0 on success and -1 on error. Receive from. Receive from system call is used to receive data from remote unconnected datagram sockets. It accepts 5 arguments: file descriptor, buffer to read info, size of buffer, flags to modify socket behavior, source address, and its size. It returns number of bytes read into the buffer on success and -1 on error. Send to. Send to system call is used to send data over remote unconnected datagram sockets. It accepts 5 arguments: file descriptor, buffer containing data to be sent, size of buffer, flags to modify socket behavior, destination address, and its size. It returns number of bytes sent on success and -1 on failure. Close. Close system call is used to terminate the connection. It accepts a single argument file descriptor. It returns 0 on success and -1 on error. Next, client-server implementation of UDP socket. As shown in the picture, the UDP server has to create a UDP socket, bind the socket to the server address, and wait until the datagram packet arrives from client. It then processes the datagram packet and sends the reply to client. The UDP client, on the other hand, has to create a UDP socket, send message to server, wait until response from server is received, process the reply, and go back to step 3 if necessary. It then closes socket descriptor